So I was asked to review radians. So let's talk a little bit about a radian. So big picture, radian is another way that we measure angles, similar to degrees. So radian is an angle measure. And then if you remember where the idea of a radian came from, and help me out, Pete, all this. So a radian, okay, comes from the idea that if I take a radius, the length of a radius, can I borrow this? If I take the length of a radius, so I'm going to use my pipe cleaner here to measure out the length of a radius. So here's one radius right here. If I take that length, okay, and I subtend it, which is a fancy way of saying put it around the circle. Put you down for just a minute, girl. I'll take you back up. Okay. So if I take this and I subtend that length around a circle, okay. In other words, this length is also a radian. I just curved the radian around the outside of the circle. And then I connect the dots, okay? This angle that's formed right here has the measure of 1 radian, okay? So this is where a radian comes from, okay? So the other thing we often want to do is we want to convert between radians and degrees. So we did some fun algebra looking at the circumference of a circle to see how many radians fit around a circle. And it turns out that exactly 2 pi radians fit around a circle. So that means 2 pi radians equals the full measure of a circle, which is 360 degrees. This gives us our conversion factor. 2 pi radians equals 360 degrees. Or if I divide both sides of this by 2, that tells me that pi radians equals 180 degrees. So this gives us our conversion factor, right? If I'm converting from radians to degrees, I'm going to multiply by 180 degrees divided by pi radians. If I'm converting from degrees to radians, I'm going to multiply by the inverse of that, pi radians over 180 degrees, okay? So let's look at an example of this. Let's say that I have pi over 2 radians, and I want to convert that to degrees. Well, I would multiply by 180 degrees over pi, okay? And what does that give us? Well, my pi's would cancel, and I'd just be left with 180 over 2. 182 over 2 is 90 degrees. So pi over 2 radians is 90 degrees, okay? Now what if we want to go the other way? Here, I'll change it, girl. Okay. What if I want to go from degrees to radians? Well, let's say we want to figure out what 215 degrees is in radians, okay? Then I'm going to multiply by pi radians over 180 degrees. We're going to keep our answer exact, which means our answer should have a pi in it. Okay, well, that's going to look like 215 pi over 180. Now we need to do some simplifying. In other words, I need to reduce 215 over, excuse me, 180. Let's see. What are those both divisible by? For sure 2. Let's see, probably something bigger than 2 too. No, not 4. They're both divisible by 2. Wow, 215 is not divisible by 2. They're both divisible by 5. Let's divide them both by 5. 180 divided by 5 is 36. 215 divided by 5 is 43. Okay, all right, I think that's probably as good as we're going to get. So exact answer is 43 pi over 36. Not pretty, but that's okay. There it is. So radian is an angle measurement. We convert from radians to degrees by multiplying by 180 over pi. We convert from degrees to radians by multiplying by pi over 180. And then remember, we have our unit circle. And our unit circle has some some radian measurements on it. So for example, 90 degrees, we just saw this, is pi over 2. 180 degrees is pi. 270 degrees is 3 pi over 2. A full circle comes back to 2 pi. And then there are other radian measures on your unit circle. You can use your unit circle as needed, of course, on the final exam. Okay? So that's radians. I kind of skipped down here. Oops. Next, let's do reference triangles. Okay, what's a reference triangle? Well, if you remember way back to the beginning of the semester, a reference triangle is one of the ways that we solve for trig measurements of different angle measures. Okay, so when we're thinking about this thing called reference triangles, that was when we were thinking about angles in standard position. So remember, standard position for an angle means that it has one side sitting here, the initial side, okay? And then we draw our angle from here. If we move in this direction, counterclockwise, our angle has positive measure. If we move clockwise, our angle has negative measure, okay? And depending on where our angle measure falls, we draw what's called a reference triangle to help us figure out the different trig functions of that angle. Okay, so let's think here. Let's have an angle that falls into the third quadrant, okay? So that means the third quadrant means the terminal side of my angle is going to be in the third quadrant. Okay, so what type of angle might be in there? Well, let's do 225, okay? So let's say this angle measure has 225 degrees, okay? Now what we often want to know is I want to know all 6 trig functions of 225 degrees. Now, one thing you could do at this point is you could go to your unit circle, because I'm pretty sure 225 is on your unit circle, okay? But before we develop that unit circle, what we use is the idea of a reference triangle. So a reference triangle says, wherever your kind of measure is, right, I'm going to drop a triangle back to the x-axis, okay? And this is going to form my reference triangle. Now, along with a reference triangle, we get a reference angle, okay? A reference angle is the angle inside this triangle. We usually call it theta prime. How we calculate theta prime depends on where our reference triangle falls. So in this case, she's just an escape artist. So in this case, right, our whole angle measure is 225. If we just want this little piece here, we would do 225 minus 180. 225 minus 180 is 45 degrees. Oh, thanks, Pete. So our reference angle is 45 degrees. We can use that reference angle. We can use that reference angle to then calculate the 6 trig functions. That is to say, we can think of, say, sine of 225 as the same thing, sort of, as being close to sine of 45 with one small difference. What's that one small difference? Well, the small difference is we need to take into account signs. I don't mean this kind of signs, I mean S-I-G-H, I just forgot to spell signs, S-I-G-N signs, positive or negative, right? So if I was thinking actual sine of 45 or cosine of 45, all of those are going to be positive because they're sitting right here in the first quadrant. But sine of 225, remember that sine involves our y coordinate, right? That's going to be negative because we're in the fourth quadrant. So sine of 225 I can think of as negative sine of 45. Sine of 45 is square root of 2 over 2. So sine of 225 is going to be negative square root of 2 over 2. Okay, so this is the reference triangle that we build. It gives us a reference angle. And if we only know kind of our basic angles, 45 degrees, 30 degrees, 60 degrees, 90 degrees, from that reference angle and our position, third quadrant, y is negative, x is negative, we can figure out all 6 of our trig functions, okay? Now, the truth is, once we have the unit circle, reference triangles become much less important. Because if I want to know sine of 225, or all 6 trig functions, say, for 225, what can I do? Well, I can hop on over to my unit circle, And from my unit circle, I can just find 225. And remember that cosine is my x-coordinate, sine is my y-coordinate. So sine of 225 would be negative square root of 2 over 2, exactly what we saw before. Cosine would be negative square root of 2 over 2. Tangent I could get by doing y over x. Cosecant is 1 over sine, so I could do 1 over negative square root of 2 over 2, which would be 2 over square root of 2, still negative, sorry. Secant would be 1 over cosine, cotangent would be 1 over tangent. So once we have our unit circle, reference triangles are a little less important, at least when we're working with our standard kind of angles that we have here, 30, 45, 60, 90, 120, 35, 150, etc.